This is the Tiny CNC Mark II, a CNC machine designed by Ivan Miranda that I built from scratch a few years ago. Well, actually, I upgraded the Z-axis assembly on it, so really it's the Tiny CNC Mark 2.5. Well, technically, I also added end stops to all the axes, so really, this is the Tiny CNC Mark 2.75. Anyways, the point is, I've put a lot of work into this machine, and I'm really proud of it, but there's still one thing about it that sort of bugs me. Its size. So in this video, I'm going to be expanding this machine along the X-axis, converting it from the Tiny CNC Mark 2.75 to the pretty decent sized CNC Mark I. Let's get started. Whenever I show this machine on my channel, I inevitably get comments from people saying 3D printed parts and aluminum aren't rigid enough for a CNC machine. And they're not wrong, but that's fine by me because I'm not trying to create a precision machine. Machining aluminum or buying high-end parts gets expensive fast, but 3D printing components, I can do that in my basement, and I do. My goal is to gradually improve this machine. If I can 3D print a machine that can mill aluminum, I can upgrade to aluminum parts. Then maybe later upgrade to steel and then adamantium and so on. But the real beauty is that I built this from scratch, so I can always take it apart, swap out components, and rebuild it better than before. You might also be wondering, why am I making this flimsy CNC machine bigger? Well, in the past couple of years, I've found myself gravitating towards building more custom mechanical keyboards for myself. Generally, I've been making the cases for them out of 3D printed parts, but I would love to get into making the cases out of aluminum, wood, or other machinable materials like polycarbonate. And again, this is a learning process. Every time I take this machine apart and put it back together again, I learn something new, or at the very least, reinforce something I had forgotten. Now, not to feed a fed horse as PETA would say, but this is another great example of why aluminum is such a good choice for beginner CNCs, because I can literally cut it on my miter saw. And these 2020 profiles are great because there's so many different ways that you can join them together to make a frame or whatever else strikes your fancy. For this upgrade, all the pieces were the same length, so I was able to cut them all at the same time, and from there I went ahead and tapped all the end holes. Now every time I'm tapping aluminum extrusion, I manage to break one or more of my taps, every single time. So this time I went and bought a bulk pack of them on Amazon, but for some miraculous unknown reason, this time I somehow managed to make it through all 16 holes without breaking a single tap. And with all the holes tapped, it was time to get started assembling. Now, one of the things that I didn't budget enough for, at least mentally, was the amount of rewiring I'd have to do. Since I was making the X-axis wider and I have two Y-axis motors, that means I need to run a new wire for the far side Y-axis, as well as both the X-axis motor and the Z-axis motor. Now, none of that is hard, and I've done it enough that I feel comfortable doing it, but it still takes quite a while to terminate all those connections and run the wires back to the Arduino. You know, even though you probably don't care what my favorite color combo is, if someone were to ask me, hey Charlie, what's your favorite color combo? Blue and orange. Without a doubt blue and orange. Which is why I was super sad to replace these cool blue tubes with a boring black cable chain. But I wanted a cable chain and I couldn't find an affordable blue one, and I didn't have any blue filament to 3D print one. I could also feel myself starting to get distracted with other projects, so I couldn't be bothered to 3D print an actual adapter plate for this cable chain. So I just made one out of plywood and it's super ugly. The next step was to mount the new linear rails. The final dimensions of this upgrade were actually determined by these rails because I didn't want to have to cut them. On the original machine, pretty much every rail I needed to use had to be cut down, and I don't have a great way of cutting steel, so I designed this new upgrade to work with standard 1 meter long steel rails. This time around, I also used T-nuts to mount the rails instead of 3D printed strips that fit into the slots, because I found after time those 3D printed strips ended up stripping, making my steel rails loose. I know, 3D printed CNC, I'm working on it, okay? The next step for me was to install the Z-axis assembly, which I made sure to do before tightening the steel rails all the way down so that I can ensure they are parallel to each other, using the Z-axis assembly itself. Then once both the steel rails were parallel to each other, I went back through and tightened all the bolts the rest of the way. At least I thought. And after giving this thing an ocular pat down to make sure everything moved and looked the way it was supposed to, I had a little bit more wiring to do before I could actually test it out. Alright, so after finishing up all the wiring and getting all the belts tensioned appropriately, I plugged everything in and the Arduino immediately exploded. Unfortunately, I wasn't filming at the time because I didn't expect anything to happen, but it turns out that I had wired the spindle incorrectly and all that extra juice went into the Arduino directly, which is obviously not good. But after installing a new Arduino, a new CNC shield, and 4 new stepper motor drivers, I was finally able to get the CNC moving again, which was a huge relief. But to absolutely no one's surprise, my troubles didn't stop there. First, I completely forgot to plug in the end stops, causing probably the first of many crashes on this machine. So I went back through and made sure I installed the rest of the end stops and did a once-over of the electronics to make sure everything looked okay, making sure to wear my Crocs for electrical protection. And after that second ocular pat down, I felt confident running a surfacing pass on the wasteboard. And everything started out looking great. I mean, it was dusty, but it looked great, until all of a sudden it stopped moving on the Y-axis and I could not figure it out. Eventually I realized that there were a couple of bolts that had wiggled their way loose and were preventing the Z-axis assembly from moving all the way over. So I tightened those down and ran another surfacing pass, and everything went as expected. Also, let this serve as your daily reminder that MDF dust is nasty. And just like that, this CNC upgrade is pretty much complete. I've got all the electrical stuff figured out, and the end stops are all working as expected now. And even though I have a way to adjust the tram of this spindle, it doesn't really seem to need it too bad. Usually with these surfacing bits, you can tell when it needs to be adjusted because they're so wide. But I was actually pretty happy with how it turned out, so let's start getting into the post-mortem. Now, obviously this machine works, and it actually works pretty well. I'm able to cut hardwoods and soft metals pretty well, which is really my only goal. However, I definitely need to reinforce the aluminum extrusions on the gantry. Extending the width of the machine definitely added a good bit of flex into the gantry, meaning that if I do any serious cutting in the center of the work area, I'll definitely have a harder time getting perfect results. I tried several things to reinforce the aluminum, but none of them had a real impact. I'm thinking of swapping them out for aluminum C-channels or even steel bars, but that'll mean redesigning the gantry plates, which is just something I haven't had time to do yet. Long term, I really want to build a Print NC. If you haven't heard of that project, Print NC is a high-performance DIY CNC router based on a steel frame, and it only uses 3D printed parts for non-crucial components. So I would love to build one someday, or better yet, I'd love for a CNC company to see this and send me a machine that's ready to go out of the box. To be honest, I just love tinkering with this machine. In a perfect world, I have this machine for tinkering and learning how CNC machines are put together, and then another machine that's just ready to go out of the box. It's similar to what I've done with 3D printing, where when I first got into it, I was modifying my printers. I had some cheap DIY type machines and was really great for learning how 3D printing works. However, after a while, I wanted to use 3D printing to take my projects to the next level rather than having the 3D printer be the project, if that makes sense. To summarize, I love that I've got way more space for bigger projects like maybe some keyboard cases, but I definitely need to tackle this rigidity issue, if I ever want to go after aluminum or any level of precision in general. Obviously, I've still got a ways to go with this machine, but hopefully bringing you along on this journey, talking about some of the struggles I've run into along the way, and the upgrades I've made to address them, helps to assuage some of the naysayers. But I think that's going to be it for this video. If you like this sort of content, you want to see me continue to make videos like this, make sure to click that like button and subscribe to my channel so you don't miss anything. Otherwise, thanks for watching, and I'll see you guys in the next one.